Hi and welcome to TRX Bench. Today we have old lady here on the bench. It is the IC-726 and well, this old lady has some dead spots in receive and transmit. So that might be an interesting fault. Maybe that is something in the PLL circuit and so it could be really interesting. So let's go for it. Okay, and first of all let's verify if we really can find the same problem here. And yeah, here already is our radio. And well, if it is really dead spots which we have to handle, then we should already hear it on the behavior of the static. And let's see. Yeah, so that is really already a very first indication. So you hear that the static is relatively low. Even I really turn off here on my gain, and when I move here over the frequencies, you hear a point where the static goes up. And I could bet that if we try to transmit in the area where the static is quite low, that we really don't see any. So let me switch to AM. Ah, yeah. Okay. So, and watch here. So no TX indication, so this is of course our transmit button here, and you see nothing. Now transmit. Alright, let's change the band, so maybe here on 80 meter. Don't know. Already nothing. Ah, okay, let me go to AM, but anyways, the indication should come even with SSB, and we definitely have nothing here. Ah, here we have a bit, and here it is gone. Alright. And I'm watching it as well on my station monitor, just to see if we have output power, and where we have no transmit sign here, we have no output power. And here you see we have output power, and now I can see here on my monitor, I can see output power. And when I release it, of course it's going away. You hear the static. Here's the static gone, and I'm pressing already here my transmit button, no TX light, and you see there is no power at all. So that are really dead spots for sure. And well, I guess that really has something to do with the subloop VCO. So let's have a look on our block diagram, and let's watch out for a good starting point. Okay, and here is a block diagram of our 726. And yeah, let's zoom in a little bit, because our area of interest is here, of course, it might be a little bit too much, is our PLL circuit, of course. And yeah, so where our components? So of course this controller I see here is producing our PLL data, which will feed our, yeah, let me say our divider and our preselector for the main VCO circuit and for our sub circuit. So we have here our voltage controlled oscillators, and these four here are for, of course, our local oscillator number 1. And normally all this PLL integrated circuits are not able to divide our reference oscillator down to a frequency that you can really go in 10 Hertz steps, or even the modern ones are going to 1 Hertz steps. And therefore we really need a main loop and a sub loop, and only when we bring both together, then we can go down to 10 Hertz steps, as we have it here on our 726. Yeah, if we watch down here, so you really can see, now I'm on AM, so let's go to SSB. So you really can see here we can go in 10 Hertz steps up and down. And all the PLL ICs are not able to do this fine resolution, and therefore we have a main loop and a sub loop, and both together are able to achieve our steps of 10 Hertz, as we have it here in our case. Well, and that is what it is all about. So only with our main loop we would be able to go in 100 kilohertz steps, or best case in 25 kilohertz steps. So that is not sufficient for SSB. So we know that we need a better resolution. So we need at minimum 10 Hertz steps. And therefore we need a subloop, and both together are now able to handle our 10 Hertz steps. So that is what we need to know. So we have here our output for local oscillator 1. We have down here our reference oscillator, and here is our output for LO2. So these are our most important mixing frequencies in the radio. And you know, if you have dead spots, it is very often that there is a problem with the sub loop, because then you know you are not really able to go over the entire bandwidth, and therefore I personally would start and check here if our locking voltages on our sub loop VCO are correct, and well, that is then a first indication. Of course we check our DC lock voltages for our four main oscillators, VCOs as well. So therefore that is what we really need to know, are the lock voltages are right, because if the lock voltages are wrong, then of course, if we get here from our loop filter our DC, which is of course for adjusting the VCO, if this voltage do not really match with the settings, then you are not able to go over the entire bandwidth, and therefore this is important, of course, here on our main VCOs, and then of course our sub VCO from our sub PLL circuit. So therefore let's simply start here and see what we have there, because the behavior we have seen here on the radio, I've seen a couple of times, and very often there was a problem with the sub-loop VCO, and therefore let's start there. Okay, and first of all we need to crack our radio open to get access to our PLL circuit that we can do our first tests. Okay, so all the screws are out here from the PA block, and let me show you this. So now when I try to get this here away, you recognize that I'm not able to really lift this unit away, so that I can put it here somewhere at the side or so, to be able to have all connections here to the PLL board, that we can do some tests. So that is what you see very often with older radios. So they did the development, so they did the production, but they never thought about services, and that is what you see here very clearly. I have really no chance to get here somehow to a point where I can have all together and have really access to the PCB. So I really need to take here this out, and I need to take this wiring out. Now I can maybe pull it through here somehow, and maybe now no, still not really. So it is still a mess, and you see here is another wiring which can't really be left in its position. And yeah, you see even now, now maybe I could put it this way to get here access to my board, because this here is a PLL board, and this is now very important for us. But you see now I have not really connected everything here to the board, so I will not get it fully working. And yeah, you see that is how it was in the past. And sometimes we have the same problems today as well, even with modern radios. So simply watch the ICOM IC-726 videos, and you see that there we have a similar problem, because the board is double-sided, and I have a ribbon cable around the board, and I cannot lift it, that I get access to the bottom side of the PCB to do some testing, and that is really a nightmare. So you see what it is. Now I try to get it in a position that we finally have these wires here connected to the main board. I believe that we can leave this wire here out of the radio, because this is for transmit operation, so that is not so important for our next tests, but these wires might be important, so I try to plug them back and find a position that we can here get access to our VCO and our DDS circuit and what have we. Okay, so I managed it here a little bit just to get it stable, and yeah, I lifted the upper here this and I lifted it up a little bit, and I tried to get the PA unit stable so that we can work on it, and I was able to simply connect these wires back. I have no chance to get this here back, but as I already said, I believe we do not really need this for doing our first tests, because yeah, we have here our VCO, so this is the main loop VCOs under this shielding, and we have here our subloop VCO, and this is our DDS unit, and we can watch it here on the pictures in the service manual, that you have maybe a better overview. Okay, and here are really our important components together. So as I already said, our main loop VCO, and you remember we have actually 3 main loop VCOs. That is because we really have to go over large bandwidth, and that is therefore split it in more VCOs to make them itself or themselves stable, and so therefore it is not only one. Then we have seen that the prescaler is very important, so that is here under this shielding. Then here is our DDS circuit, our DDS unit, and here is our sub loop VCO, which are all shielded, of course, and down here, so this here is our reference oscillator, and that is now where we need to get access to, and then we can start and try and look out for our locking voltages. And again, the watch into the radio, main VCO, sub VCO, DDS unit, prescaler unit. This, by the way, is the first LO amplifier circuit, and as this is here our sub loop VCO, I really like to check this locking voltages first. So let's see where we can find our sub loop VCO, and then we can directly check our locking DC voltages. And of course, therefore, we have in the service manual our PLL adjustments, and I believe that we really have to go through all these steps, because this is an old radio, and after a period of time radio really needs realignment. But first of all, let's see what we have, and yeah, here are our first LO lock voltages here, and Of course, we have to check it with 1, 2, 3, 4 frequencies, simply due to the fact that we have these 4 VCOs and DDS loop. So let me check. Okay, so you may see it now. They call it DDS loop adjustment, and it was a sub loop VCO in the first picture, so they are changing the wording for it anyways. So this is a DDS loop adjustment, which was called sub loop VCO on our first picture. So that means okay, so that means that here our DDS loop alignment is of interest, and you already see here we have to dial in a frequency, and we have to connect an oscilloscope. So that is bullshit. So this is a DC voltage, you can see it here, and I take my Agilent multimeter for that. So we have here our log voltages with 2 different frequencies, which we have to dial in on the front panel with our main dial. And then we need to check here this both locking voltages at, let me see, connect the oscilloscope to R133. And therefore we go then back here to this picture. And right, so here is R133, and that is a DDS loop checkpoint. So that is what we're gonna do first. And then we check, of course, here this voltages, this log voltages, of course, as well. Okay, and here in real life, so let me zoom in, you see that we have our R133 really down there. So that down there is the checkpoint where we need to check for our log voltages. Okay, and first of all we have to do our pre-settings, and as I already said, we have to dial in 14126.50. So that is the frequency we have to dial on, and the radio needs to be set to AM mode. I lock now here the setting that we cannot accidentally change it. And now with this frequency we have to go down to our R133, and we have to check the voltage down there. Okay, and down here at our test point we read 3.8 volt. Oh, okay. Let's see if I can show here our manual once again. So you see we should read 1 volt, and with, let me go over there, with 126.49, so that is 10 Hertz lower, we should be able to read approximately 2 volt. Okay, so if what we are testing is right for the moment in time, we have 2.8 volt. So the voltage is 2.8 volt too high. So back here to our testing. So you see at R133 we are testing 3.876 volt, which is of course 2.8 volt too high, so we should read 1 volt. Okay, so let me go this 10 hertz down. Let me see. I better leave it here on the meter. Let me go 10 hertz down, and then we should go to 2 volt approximately. So that is what our manual is telling us. So that is 4, 9, so 10 hertz lower, and you see we have now 4.7 volt, and we should read 2 volt. Okay, so the subloop VCO DC locking voltage is much too high. Okay, just to verify if we are doing right, let's go to the main loop and let's do the same testing on the main loop VCOs just to see if we may do something wrong here. Okay, and that is what our manual is telling us. So we start with the first VCO, and our test voltages should be always 6.5. The second VCO with 14,999, 6.5. The third with 21,999, 6.5. And the fourth VCO with 33 megahertz should be 7.5 volt. And that is what we gonna check now, and these voltages are present at R77, and yeah, let's go down to R77. Let's dial in these frequencies, and yeah, then we compare if these voltages are good compared to what we have seen here on the subloop. And the test point is the R77, and the R77 is down there. So there is our R77. Don't know if you can see it. Just want to show it here that you have an idea where I am with my probe. So there is the R77, and that is our test point. And yeah, I think you have a rough idea where we are. And now I have to dial in the right frequency. But let me here go back to our voltmeter, and I have to set at first in the 40 meter band, I have to set 799, so 7 and then all are nines, and we have to set it to upper side band. I'm not there. Takes a little while, sorry. Okay, so now we are on 79999, and you see we have 6.6 volt, which is very close to our 6.5. By the way, if you watch once again here our voltmeter, so I go back here to my frequency dial, and you see with changing frequency on the main dial, you see that here our voltage is changing, and that is of course what we want, because we are changing the frequency of our voltage controlled oscillator, because that's the reason why it is called voltage controlled. You see, of course, here a changing voltage, and of course we need to have a certain frequency which we can test against, and that is here in our case our 7.99999, right? And at that point we should read our 6.5. We're a little bit too high, so that means we need to do a fine alignment here on that VCO as well. But let me go to our second VCO, because of course this is here our first VCO. Now let's check our second one, which is on the 20 meter band. So we need to go to 14.99999. Was it a 9 too much or too less? I have no idea, but you know what I mean. So we need all 9s. Okay, let me see. Now we are at 14.99999, and what you can see here again, we have 6.49, so that is really very close to 6.5. So this really wouldn't need an alignment, so that is really intolerance, no problem whatsoever. So now the same with the other two VCOs, but I don't do it here on the video. It's taking too much time, but I let you know when I really know what's going on. And yeah, we have a first indication it is really something wrong with our subloop VCO down here. And yeah, when I have now checked the third and the fourth VCO, and when this both VCO more or less okay, then we really need to open here the shielding, and maybe first I will fine align here the main loop, but then we are really at the point where we need to open here our little shielding to get access, and we try to bring the VCO to the right locking voltage back. Well, but to have really everything right, so you see down here is our DDS loop where we have the wrong voltage. We have two settings we have to do before, and that is here the DDS clock frequency, and so that is the frequency we need to check, and maybe we have to adjust it, and then we check our reference frequency as well, that we really need that we really read here our 6144 megahertz. So that is very important, and it is very important to check if the output level for our reference frequency is on the right level. So that is what we have to check as well before we go down to our DDS loop testing. So let me do this tests here before. It would be really the wrong way if these values are far out, and with these levels far out, it doesn't make any sense to bring the DDS loop locking voltage to its right level. Okay, our DDS clock frequency is slightly out, so at the last digit we should read an 8, and therefore you already see I'm adjusting the DDS clock frequency. And now it's jumping a little bit. Let's see if we can get it stable at 8824288. So that is not too bad. That is not too bad. So that is how we can leave it. Okay, the next test is the level of the reference frequency, and we have to test it with a 50 ohm termination. What we have here, and our service manual is telling us that our level needs to be more than plus 3 dBm. And of course I have already connected here my level meter, and you can see that our level is 3.8 dBm. So that is more than 3, and that means that the level output terminated into 50 ohm is just fine. And the next we have to check is the frequency of our reference oscillator, and it should be 614400, and that is really exactly on frequency, so I haven't changed it. I've done really nothing. You see, it is simply just fine. Great. Yeah, and now we are already at the step where we have to adjust our DDS loop locking voltage, and yeah, if I see this here, I wonder if this has been open before. I mean, we see the same flux residues here as well, and I wonder if it was open before. It does not really look like as it comes from factory, but well, okay, it is an older unit, so maybe, I'm not sure. Okay, our subloop VCO is open, and you see down here this coil, and that is L30, and we have to change the locking voltage with this L30, and you see, therefore we need to change here the distance between the windings here, and that is always a little bit tricky, but that is how it has been done at the time where this radio was developed. Okay, so let me see if we can change our lock voltage. We have dialed in the right frequency, and now I go down here to our coil and I try to change here the distance, and let's see what's happened. So something is happening, but oops, oh hola, so it is already doing something, and you see that is already a difference. Oh yeah, so it is still too high, but you see, much better, much better. Not entirely. Here, have a look. So we are really getting closer, So we are trying to get it to 1 volt. Okay, so you see it is still increasing a little bit, which is just fine. Let's see where it settles down. You see we are already very close to 1 volt. So that is here definitely a huge difference. You see it takes a little longer. So let me try to get it here stable, and then I will be back. Okay, so that is now the setting. We are very close. So that is just fine. Much better than we had before. So let me change it to 4.9, so 10 hertz down, which is it is still locked, which is here, and fine. So approximately, so that was the requirement, more than 2.0 volt DC. We have definitely more than 2 volt. That means we are now exactly in tolerance. So when I go now back to 765, sorry, 765, which is here, we are very close at 1 volt, and when I now go 10 hertz down, we are over 2. Exactly. That is just fine. So that is the setting we are looking for. Okay, so when we start with this repair, we recognize that we have a lower and a higher static, and that is what I want to check now, because I'm not able to connect my PA for the moment in time, so therefore I need to put back here our PA unit. But we can check for static, so we start at come on, we start here at 14. I increase our static, and now let's go over our band and let's see if we hear a difference in static. Not really. And what you can see here as well, so now our let's turn it down. Our subloop VCO is now cycling between 1 and 2 volt. If you watch it here, so when we start here, for instance, at 14, we are close to 2 volt, and now when I go up to 350, as we know it, we see our subloop VCO is cycling between 1 and 2 volt, which is exactly what we expect, and we do not hear this changing static noise, so that is more or less equal. And I'm quite sure that when we do now our testing, that we will have output power at all frequencies where we haven't had output power before. Okay, now we can really check for output power. So we really start here at 14 megahertz, and let's see. So you can see hopefully the dial, and you see the output power, I believe. And now transmit TX is there. So I've really reduced here the output power to a very low output power, that we do not really heat up here our amplifier. It is just to see if it is working on all frequencies. And output power and output power, output power, fine, output power, no problem, no problem, output power. So you see already we have really output power over the entire 20-meter band, and that was not the case before we had fixed our fold in the sub VCO. Okay, and let's do the same on the 80-meter band. So we remember the 80-meter band was the worst band we have seen. So we start at 3.5 megahertz, and let's see, output, no problem, output power, output power, output, no problem, just fine. So you really see it is working just fine. So we really had a problem in our sub loop VCO, and yeah, that can be fixed as I have shown it. Okay, and of course, to finalize this repair, I will adjust here our main VCO locking voltages as well, for sure. I mean, we have seen that we have little tolerances, and I will of course do all the other checks which have to be done here in the PLL circuit, but that is now only adjusting, which is really not very exciting. So you have already recognized that it takes time to do all the fine tuning. So therefore I will not do that on video, because that is basically exactly what you have seen when I was adjusting here the frequency, and when I was here tinkering around with this coil here to get the right DC voltage. So that is really boring. So I think you really have seen the essential point, what you need to do, what you have to consider, how you can start, how you can find your starting point. And so I hope that this was a lot of new informations for you, and therefore I will stop the video here, and radio is more or less back to work, and therefore thanks for watching, and if you like this video, please give me a big thumb up, and catch you next time. Bye.